So last time we talked about how to multiply radical expressions, and today we're going to focus on how to divide radical expressions. So when you have a square root divided by another square root, you can put both of those under the square root and divide them both. So square root of a divided by the square root of b is equal to the square root of a over b. Let's take a look at an example. So divide the following expressions. Be sure to write your answer in simplest form. So we have the square root of 1200 divided by the square root of 4. So I can divide 1200 divided by 4 and put that under a square root. So that's going to be the square root of 300. Now you want to make sure that this is written in simplest form. So you're checking to see whether or not there are any perfect squares that are factors of 300. In this case, 100 is a perfect square, that's a factor. So we can write this as the square root of 100 times the square root of 3, and that gives us 10 root 3. All right, in the second one, we're dividing the square root of 162, y to the 5th, by the square root of 3y squared. So I can first write this as all under one square root. So this will be the square root of 162y to the 5th over 3y squared. All right, now dividing 162 divided by 3, that's 54. And y to the 5th divided by y squared is y to the 3rd. Now we want to write this in simplest form. So let's check to see if there are any perfect squares that are factors of 54 and y cubed. So for 54, we have 9 as a perfect square, that's a factor. And for y cubed, we have y squared, that's a factor. So we have the square root of 9y squared times the square root of 6y. Now I can simplify the square root of 9y squared, and that becomes 3y. So this is equal to 3y times the square root of 6y. All right, the next thing we're going to talk about is rationalizing the denominator. So rationalizing the denominator means rewriting an expression so that there is no radical in the denominator. Now, there are a couple of ways to do this depending on which case you might have. So in the first case, if there's only a radical in the denominator, then you're going to multiply both the numerator and the denominator by that radical that's in the denominator. So for example, if we had 2 over the square root of 3, in the denominator, we just have a radical, we don't have anything else. So what we're going to do is we're going to multiply both the numerator and the denominator by the square root of 3. So I'm going to multiply by root 3 over root 3. Now in the numerator, that leaves us with 2 root 3. In the denominator, when you multiply root 3 times root 3, that gives us the square root of 9. Now the square root of 9 can be simplified to be equal to 3. So now we no longer have a radical in the denominator, so we have successfully rationalized this denominator. Now on the other hand, if in the denominator you have an expression that contains a radical, so there's more than just a radical there, then you're going to multiply the numerator and the denominator by what we call the conjugate. Now what is the conjugate? Well, let me give you an example. So here we have 5 over 1 plus root 3. Now I'm going to multiply both the numerator and the denominator by the conjugate. But what is the conjugate? Well, you're going to take a look at what you have in the denominator there. We have 1 plus root 3. And that expression, if we were to switch out that plus to be a minus, so essentially we're going to make it the opposite sign in between, that's the conjugate. Now if this were 1 minus root 3, then we would change it to 1 plus root 3. So I'm going to multiply both the numerator and the denominator by 1 minus root 3. Now this is going to take a little bit more work because we need to multiply 2 terms here, but it still works the same. So we do 5 times 1, that's 5. 5 times minus root 3, that's minus 5 root 3. And then on the bottom, we're going to do 1 times 1, that's 1. 1 times root 3, that's root 3. 1 times negative root 3, that's negative root 3. And root 3 times negative root 3, that's negative root 9, which is equal to 3. All right, now it looks like we still have radicals in the denominator, but notice how the positive root 3 and the negative root 3 here are going to cancel. So that leaves us with 1 minus 3 in the denominator, which is equal to negative 2. So actually now we no longer have a radical in the denominator, so we have successfully rationalized that denominator. All right, let's take a look at example 2. Rationalize the denominator. Be sure to write your answer in simplest form. All right, so for both of these, it looks like we just have a radical in the denominator. So we can multiply both numerator and denominator by the radical in the denominator. So for this first one, I'm going to multiply by root 5 over root 5. So multiplying this, we have 4 root 5 in the numerator, and then the square root of 25 in the denominator. Square root of 25 simplifies to 5, so we have 4 root 5 over 5. And now you see how we no longer have a radical in the denominator, so we have rationalized that denominator. All right, for 8 over root 2, same thing, we just have a radical in the denominator, so I'm going to multiply both the numerator and the denominator by root 2. So multiply by root 2 over root 2, and now we have 8 root 2 over square root of 4. Now the square root of 4 is equal to 2. And now we want to see if there's anything we can simplify. In this case, we have 8 divided by 2, and we can simplify that down to 4. So that's going to be equal to 4 root 2. All right, let's take a look at example 3. For these ones, you see we don't just have a radical in the denominator, we have some expression that contains a radical. So these are the cases where we're going to have to multiply by a conjugate. So for this first one, 7 over 3 minus root 2, I'm going to multiply the top and the bottom by the conjugate, which is 3 plus root 2. So I'm going to write that out, times 3 plus root 2 over 3 plus root 2. All right, now let's go ahead and multiply this out. So 7 times 3, that's 21. 7 times root 2, that's 7 root 2. 3 times 3, and that's equal to 9. 3 times root 2, that's 3 root 2. Negative root 2 times 3, that's minus 3 root 2. And then negative root 2 times root 2, that's minus root 4. And then we have this 9 minus the square root of 4. So 9 minus 2, which we can simplify down to 7. And then the 3 root 2 and the minus 3 root 2 are going to cancel each other out. So that leaves us with 21 plus 7 root 2 all over 7. Now if we can simplify, we should. So in this case, both 21 and 7 root 2 go evenly into 7. So 21 divided by 7 is 3. 7 root 2 divided by 7 is root 2. So this is 3 plus root 2. All right, for the second one here, we have 4 over 1 minus root 3. Again, we have an expression that contains a radical in the denominator, so we're going to multiply by the conjugate. The conjugate here would be 1 plus root 3. We multiply both the numerator and the denominator by 1 plus root 3. All right, so 4 times 1, that's equal to 4. 4 times root 3, that's 4 root 3. And in the denominator, we have 1 times 1, that's 1. 1 times root 3, that's root 3. Negative root 3 times 1, that's negative root 3. And negative root 3 times root 3, so that's negative square root of 9. Now in the denominator, that square root of 3 and the minus square root of 3 cancel each other out. That leaves us with 1 minus 3, the 3 coming from the square root of 9. And then 1 minus 3 is equal to negative 2. And then we can actually simplify this a little bit further because we can divide 4 by negative 2 and 4 root 3 by negative 2. And that's going to leave us with negative 2 minus 2 root 3.